Ready in the land of YouTube.
All right, guys, I'm gonna get started. I'm gonna grab a seat real quick. I know you guys are probably like, hey, 2 hours of Internet of Things, but it's gonna be more in detail. This one, it's gonna get more low level. Hopefully, you guys learn a thing or two. So I'll get started. My name I work for Belkin, so I'm coming more from the manufacturing side. You know, we have Belkin owns Linksys, so the routers, and the routers are controlled via your mobile app too. They're the same thing as Internet of Things. They also have our home automation suite, Wemo, same thing. Control your smart home via your mobile app, things like that. I'm from the LA area. I'm on the OWASP board for Los Angeles Cloud Security Alliance and something called HCCIA. There's my Twitter handle. If you guys want to follow me, I do a lot of IoT research, embedded, mobile security research. So go ahead and follow me there. So I'm going to talk about a little bit of what last time, get really low level, really detailed, kind of describe things you guys may not know about how these devices are created. I feel like everybody has their kind of like their input, but they don't really know exactly what it takes to build these devices for consumers and mass deployment, mass production, all the different teams that are involved. So I'm going to talk about that and talk about the problems that we have and how we can solve it, and basically the supply chain and the big problems that the FTC and other people aren't really looking at. So, I'll just go over light introduction of Internet of Things. I'm not going to say this word for word, but you guys know it's just network-connected devices, all embedded technology, different type of OSs. You can control them, like I said, via a mobile app for the most part, or whatever it is, a web interface, whatever you have, just remotely is the idea. And again, here's something I got from Postgres. They have everything from IoT resources you can think of. If you want to learn about IoT, I would suggest navigating there. I actually have the URL there. I'll kind of post it up. It's very, very tiny, but I don't want to take up too many real estate. But I'm not going to go over everything. You guys kind of know what IoT is and how you can apply it, the different types of business use cases and things like that. So we talked about hardware last talk. I'm going to talk about a little bit right here, how cheap these devices are. We talked about Arduinos and Raspberry Pis and these pan stamps here, which are, I think, like $5 just to create this device. That you try to, whether it's a POC, whether it's for mass production, the idea is that you have an idea that you want to implement for whatever reason to help your life, someone else's life. So what it takes, it starts with the hardware. It starts with an OS or a framework. People can build off of a Linux kernel. They can build it off Windows, embedded platform. They can build it off of frameworks that build upon, are compatible with Linux. So Aldrin has their own. Riot, HomeKit is just another platform, basically, that you can have accessories, you have rooms and things like that. You can control via your iPhone device. But OpenWRT is pretty common. You also see things such as RTOS, which is real-time operating systems. That's basically a stripped-down version of OS. It's, believe it or not, the Linux embedded systems. They're too much overhead. And these devices are tiny, so a lot of these sensor devices, very, very small devices, they use something called RTOS. So, there's no unnecessary drivers, that it's only what's needed to perform your actions. And there's people like VxWorks who create RTOS operating system, really open source. But they're also not only for IoT devices, but they're also anything embedded, like routers, for example. You see a lot of I'm not going to name companies, but security vulnerabilities in, VxWorks type of platforms, and it kind of goes from, maybe 3 vendors will use them: Belkin, D-Link, Netgear. We all, we could all use the same type of ODM, is what they're called, in the same platform. So with these IoT devices, they control, you control it, via your mobile app, but there's always an endpoint, a web service endpoint in the cloud, AWS, Azure, VPS, somebody else has spun up cloud infrastructure. So there's different aspects. We're talking about hardware, embedded, cloud, mobile. It's a lot of technology here involved just to get these devices to do what you want them to do. I think it's called everything here, and it basically provides that platform for you, as well as the hardware, as well as kind of like a boilerplate of code. You kind of just tweak it to whatever you need it to do, and get your prototype and your device out in production. People can use it, test it, and you can iterate through it. The different protocols that these devices talk. There's not one type of protocol that is being used right now. There's a ton. There's a whole list here: NFC, Wi-Fi, Zigbee, Lutron. These actually lights here are controlled by Lutron, which is a proprietary wireless frequency, I guess you could say. It's all RF, just different bands, different. You get 933 for Zigbee, also 2.4 gigahertz, and everything else is on. Bluetooth Low Energy, like we were talking about, locks usually are on BLE. An NFC. And they all have different functions, but they all have to communicate. So they have like this abstraction layer, basically that converts it to whatever layer 7 protocol they're going to be using, a REST API, SOAP XML, things like that. So again, here's the protocols. MQTT, I was talking about REST and GSM, things like that. All these devices communicate over these protocols, and again, it's kind of like everybody's building their own. The ecosystem is really not being friendly. So in order to make these guys kind of all play together and play nice, you need something called a hub. A Wink hub is basically Wink, Insteon, there's smart things there, which is Samsung's device, and it basically bridges all these protocols together. Like the Wink, for example, it has Zigbee, it has Bluetooth LE, it also has Wi-Fi, and then I think it has Z-Wave as well. And then from there you control it via just the Wink app instead of having like 5 different apps. One to control your lights, one to control your lock, one to control your garage door opener. So kind of just one centralized device that actually communicates and translates over Wi-Fi over to their hub. So Wink has an API that these partners like GE and Chamberlain and things like that they abide by, basically. It's pretty open source. It's all REST API. We talk about how many devices are going to be here. Even by next year, 4.9 billion according to Gartner. I know I have a ton at my house. My house is filled with motion sensors and cameras, and just every time I walk up my stairs, my lights are on, my room's on, I have a plug that actually measures how much energy I'm using, how much energy I'm saving. I have lights grouped in certain ways, because Zigbee can form mesh networks. And auto heals too. So if something goes off, kind of fix each other. And you have your own kind of like coordinators, basically that helps each other. So each protocol has their own, pros and cons. Wi-Fi overhead, Zigbee is low powered, basically, not as much CPU intensity on the device. Like I said, they're very small. Not a lot of resources to take advantage of. So I'm going to get started very, very low level. The PCB board, really the print circuit board. I don't know if anybody has any hardware background, but there you start with the pads. Pads are actually what you solder to the chip to, and then the leads, basically. You know how you see let's see if you have them here. Probably can't do it. There's usually like you have a board, and then you're gonna solder, and there's the pads right there, and these are called leads on the side that actually solder to the board. And the traces are actually, the circuit traces that you see. That's actually what they're called. And you have silk screens, things that actually have on the board describes, RX, TX, things like that. You can have a number of silk screens. You can use silk screens to even hide things if you want, because these boards have different layers, mostly just for electromagnetic issues, analog and digital issues as well. You have to put analog on one side, digital on the other. Depending how you're creating your product, if you need any of that. And then even just to put these boards together, some of these chips don't have leads. So, you get a chip like a wireless chip or a CPU, and in the bottom, you're like, well, how do they solder these things? There's nothing for me to solder. But basically, it's just, it has solder and flux in the bottom of it. You just have to heat it up with the oven, and that's what this is right here. It's called reflow. And that's how it just metal sticks to metal, and it sits together. And that's how it communicates with the copper and all the traces. And from there, you actually get communication between devices within the PCB board. And then you get the BSPs, the guys who create the drivers, the Marvell guys, the Broadcom guys. You guys probably seen these in your wireless drivers. You go in your wireless network, and you can try to find networks to join, and you'll see Broadcom and Marvell typically. But these guys are usually the big names. So you always hear about like open source issues, like how can I put this? So they have for example, I work for Linksys. We have OpenWRT routers, and there was a big issue where the community got mad because we didn't have, it wasn't true open source because they didn't have access to the wireless drivers. In reality, it was these guys, the BSPs, it was, who didn't release the drivers for us so people can fix issues and they couldn't tweak the drivers to how they wanted it. But basically, it starts with these guys. They create the drivers to communicate to that board. And again, it's just a binary blob, actually, so you have no insight as to what kind of code it is and how they're writing it. So if you're going to look through it, you're going to have to reverse it, and it's going to be in C. Or even something even lower than that. And you have ODMs. ODMs are a dime a dozen. They're everywhere. They're the guys who basically create their own software stack, throw it on there, and they have their coding is ridiculous. They're usually startup companies. What they do is they'll get somebody like an ODM. It could be a group of 10 people. Just coding, a UI stack, and then communicating to the device, just to do basic functionality and making it work. And they provide their own APIs for, let's say, an OEM, someone like Belkin, to communicate to and add their own functionality to it. So it's like, they'll provide Linux kernel, they'll provide some packages, some basic functionality between the device, and then, they give an SDK over to the OEM who then puts their own stack, we put like a Belkin name on it, whatever it is. And they also have their own cloud infrastructures now, like I was showing you guys before. They're also ODMs. So like I said, so we have, there's a ton of them in China. There's so many names. It just depends who's coming out with what first. Big manufacturers choose them to use for their project. So, just because there's so many of them, usually we have 6 or 7 at Belkin that we actually stick to. For different drivers, whether it's like our media server drivers, or we have our Samba drivers. Again, those are all third party, all for one code base of your embedded device, whether it's a router, IoT device, a wearable. There's still different drivers, different code base, different teams, different countries. It's kind of everywhere right now. So it's kind of hard to expect some sort of secure code. You can't get one team to code securely. How are you going to get people from around the world to code securely? So back to these cloud providers, like these ODMs, spin up. We have the Amazon guys, the Google. ThingsWorks, and again, they have their own set of SDKs. So not only do you have the ODM SDKs, you have the cloud service provider SDKs that the ODM talks to, or you as the OEM would then connect to the cloud APIs. So it's kind of like a big a tangle of technologies and troubles and and I mean, you guys have probably heard the privacy issues. You'll see one device actually connecting to 10 other infrastructures. You'll see it. You have companies like Zipiter who are doing research, not really mining, but kind of to protect their own privacy and see where actually these endpoints, these IoT devices are talking to. So it'll kind of carve. You'll see just general thing, not even IoT device, but like Netflix. So you'll see 4 Netflix clusters that they usually talk to. But like Belkin, we'll talk to Amazon, for example. And then we may have an analytics thing, maybe a Splunk thing or something like that. But nothing personal, if you guys are curious about that. Just usage. So again, ODMs, that's us. Belkin, Linksys, we will resell it, we support it. We get all of the PR crap, basically, that we have to put up with from researchers, from journalists, from people trying to make a name for themselves. We're the ones who offer support. Warranties and things like that. So just remember, we don't have the code in house, so it's not something that we can fix. Hey, yeah, come on, guys, let's work on it. We have to inject something into somebody else's software development lifecycle, whatever it is, and you have to QA it. So it's a whole process. So if you're using ODM, for your product, you can build everything in house. Just some people choose to outsource like everything else because it's cheaper. And again, like I said, mostly it's in China. Typically, it's in China. And I've talked to these guys. That, I do these pre-engagements with. We're trying to build out new products, and I talk to these guys, and they have no idea. They're like, "Yeah, it's secure, HTTPS, 128-bit." I'm like, "Dude, no. Like, there's so much more you have to do. You have an embedded device, you have hardware, software, mobile, your cloud. I'm like, what type of change control processes do you have? What type of, do you guys have VPCs for your Amazon backend?" And like, I don't even know what that is. Dude, what's your access controls? Do you whitelist? What's your partner? They have nothing. No type of policies, no type of guidelines. They're just flying the seat of the pants and just trying to get a product out. Like I said, they're usually like teams of like 10 people. There's small companies, but there's a ton of them out there. Just people who can code is basically who it is, and they're making good money out of it. Some of these people actually are relatives to people who work in the BSP, like the Marvell, Broadcom. Like they'll have their own kids or whatever. They grew up with them, and they'll become the ODMs, and they'll kind of spin up their own company. But now they have a direct distribution relationship with them, with the BSP, and now they're ODM. They can create a partnership for just for a project basically. So here's the supply chain I was trying to describe. If your BSP, your ODM, your cloud service provider, and then your OEM, and then you ship it out to the world. Like I said, it's all these teams are everywhere. You have Broadcom's in California, but I'm sure they outsource things to like India, outsource things to Korea, everywhere else, China. And these devices are being manufactured for the most part in China. So who's doing integrity verification there? Nobody. It's just people are just putting it together and shipping it out. And then who's looking at security in all these aspects? Well, we are for OEM side, but from top level down, it's kind of hard to make sure all these different teams, probably 4 or 5 teams within BSPs, ODM, CSPs, BSP for sure, Marvell, Broadcom, they have like 30 teams at least. So again, from around the world, different teams, different places, different coding styles, different coding standards, different languages, different frameworks, platforms, instruction sets, ARM, MIPS, whatever it is, it's all different type of code coming from around the world. And these people aren't really worried, again, about security. They usually, like I said, small teams, sales guys, project manager guys, or program managers, and your engineers, the guys who are doing the work. That's all their team, they're not focused on anything with regards to security. So sales, obviously, we call business development. Let me, get some more customers. How can we get more projects to work on, get some more money? Outreach out, create a relationship between a distributor or BSP, things like that. PMs, like anything else, project managers, program managers, prioritize, make sure the team's set for their, with their goals, just objective-based. When you have your engineers, just work, writing code, not much, quality assurance being done, probably some unit tests and maybe some automation going, but nothing really in depth, right? So, and again, you have, your different, UI and UX user experience, different type of coders, jQuery, JavaScript, HTML, front end. The back end is connecting, to your firmware, whatever, abstraction layer or application you're looking at, you're using REST API or whatever it is from your mobile device, and to make sure the transportation between the hardware to the mobile to the cloud is all secured. How are you going to do that without messing up user experience and taking too long for something to, to actually work? So here's the hardware side. There's lots of talks on hardware security and exploitation and things like that. There's you need UART, which is your serial, asynchronous serial inputs. Basically, for manufacturing, you need a UART connection to make sure, for example, routers, your WPS pin set correctly, your WPA2 password is random, or for just verification that the firmware is actually loaded on the device before you ship it out. Some places, ship with JTAG too. JTAG is like another debugging interface for manufacturers. I don't know if you guys know JTAG. Everybody's always like talking about, I just JTAGed it. It's like, yeah, but what is JTAG? Like, how are you JTAGing? There's not a lot of info out there, and it's usually kind of undocumented, so you have to use some sort of tool to, or figure it out basically. But you can just pull firmware from the JTAG interface. With UART, you can just, it's almost like terminal access. Some people have it authenticated, some people don't. Then you have your SPI, your SOIC, your I2C on the board, kind of lower level, where you have tools like Shikra, the Zippiter's Shikra, that actually uses all three, UART, SPI, and JTAG. You can sniff everything from there. You can pull firmware from various vectors. You can use, if a board only has UART, I'm going to use Shikra, or you can use Bus Pirate too, but there's little reasons why you would want to use Shikra over Bus Pirate for timing reasons. Sometimes you get a timing issue with Bus Pirate, it won't work, but that's basically plugging in, soldering in, or have pads that solder into the UART headers on the board. You have JTagulator, a lot of tools to actually do these hardware exploitations on these devices. Flash ROM, obviously you need your multimeters to see what energy is being output. So if you have 0, if you have 1, usually if there is something being outputted, that's a transmit pin. So okay, I'm going to solder something there. My UART connection. And you have your chip quick to take off chips, it's if people try to hide their UART or JTAG interfaces, you can just use chip quick, take whatever it is off, heat it up with like a blow dryer. It takes it off pretty easy, but to put it back on, you don't want to use something like chip quick. You want to probably resolder it on, or if you don't jam your board already. And then you have embedded general, operating system security on the device. Like I said, it could be Linux, it could be Windows, it could be a real-time operating system. You have your tool chains, your libraries. It could be your HTTP libraries or UPnP or anything really, and how you actually configure it. And again, have some common attack vectors and less common. Usually application layers, okay, I'm going to go through the web interface and try to pull something from the firmware rather than the hardware aspect. So you're exploiting via software rather than hardware. So you have your different interfaces there. And again, your kernel exploits are getting ridiculous now for Linux. There's 115 as of last year, actually, CVEs, and some of them with exploitable code, some of them not. But just to think of these devices using Linux and how many vulnerabilities are out there, because they're usually old kernels. Just the way it happens. I don't know why. By the time it's not like a SaaS type of workflow for the developers. You don't have the agile as a true agile. You have to do these firmware updates, and you have to rely on the customer. Otherwise, they get mad because their device rebooted in the middle of the day or whatever. They need access to it. So it's not something that you can just force on them. You could opt in to auto update, but again, sometimes they get kind of mad. We did that a couple times in Linksys, and it wasn't really a good idea. It was a bad idea. It's good security from a security perspective, but UX, that's the whole battle. When you have consumer products, it's not like I said, it's not like a SaaS, a web app where you fix one, you fix them all. You're going to have some outliers on there, and you're relying on the consumer to actually be aware of these issues, be aware there's a new firmware update. So it's our job to make sure, they log in, hey, new firmware update, please update security issues. You need to update now. I would highly recommend it. So you have hardware security, embedded security. You have wireless security. Different RF frequencies I was talking about with the protocols. There's plenty of tools, frameworks, and hardware devices to exploit these different protocols. So Zigbee, you have the Killer Bee framework. You use these AtMel, little USB dongles, upload custom firmware that the Killer Bee has. And then from there you can sniff and inject Zigbee packets. So 802.12.4 is what Zigbee is. And Zippiter is going to release the RF Zigbee, so specifically for Zigbee, retrieve and transmit packets in Zigbee. So all these light bulbs basically, they're based off of Zigbee because you can group them, and again you can create a mesh network by grouping them, and they auto heal themselves. So you can put, okay, my lights in my living room, my lights in my garage. I want those to be one group. I want lights in my room to be one group, and they all communicate over, it is SSL encryption, 128-bit, but you go on Wireshark and the key's there to decrypt it. So honestly, there's no point. And then I think a couple months ago, actually, Link is actually Zigbee's to license a Zigbee device. You have to, by Zigbee Alliance, you have to get like a certification. Basically, you have the Zigbee logo on there, and they give you like this symmetric key to actually sign the device. Everybody has the same one: GE, Balkan, Osram, Slovenia, and that got leaked like 2 months ago. So that was their whole way to keep it secure, and now everybody can create their own, update their own lights if they wanted to using that key to create these linked devices. So it's pretty scary. You have the normal 802.11 wireless attacks, aircraft, things like that, Wi-Fi. A lot of people rely on their home wireless network security. WPA2, I'm good, I'm safe. No, not really. There's so many ways to get past that now. Me being at a router manufacturing company, I see some crazy things. People, it's like your router's not even there anymore. You're like, wow, how the heck did that happen? But just by you clicking on something, it opens basically like a door in your network sometimes, straight to your computer, depending on what payload or something you clicked on. Very, very simple, especially through your browser. You have things like NAT, network address translation, basically public internal IPs. It traverses that easily. With say there's for example, outdated version of NAT PNP library in the firmware, and you're vulnerable, and there's Metasploit modules out for it, and you as a consumer, you haven't updated your device on your wearable, your power switch, your router, and anything that goes out from your network leaves that pinhole, that port open, so anybody can just straight traverse your network and hit your devices inside your local network, and you're not, it's like you don't have a firewall. There's nothing there, and all they need to do is have something open from the inside to create that door to be open and that attack vector to be live. So then you have Z-Wave here. Z-Wave's a different type of protocol, as the same kind of licensing model as Zigbee, where the Z-Wave, I don't know if they're Alliance, I don't know what it is, but you have to go through their certification standards. Same thing as Wi-Fi too, wireless Wi-Fi Alliance, you have to go through their standards. You have to have WPS, unfortunately. I've been trying to get that thing off. I hate it. So Z-Wave, there's a framework called Z-Force that's used just to attack, sniff, and inject Z-Wave packets too. I think there was an article and a couple talks at Black Hat on hacking Z-Wave home automation systems. It's very interesting. And there's Bluetooth LE, low energy. TI actually has a ton of boards and helps you out with actually creating, sniffing, and injecting devices to secure your network. They have everything from Zigbee, wireless, Bluetooth LE. I don't think they have Z-Wave, but I think they have another one, NFC sniffers. I have it in my notes, in my speaker notes here. It's actually ti.com/tool/packet sniffer. And it has everything. It tells you the board, what board you need, what chipset you need, and then it gives you like a Windows binary tool to basically install so you can see all the packets and inject and sniff and whatever you want to do. So it's freely available. All these things are out there. Just people aren't really looking at it yet. There's only like a certain number of people, actually. A couple companies, researchers, people doing it on their own time. That's TI. TI is kind of famous for this C1111 chip, transmits and receives. These are the little chips that people are stealing cars with. You get these little grill toys, and you has a JTAG interface. Upload your own firmware, and whenever you click your car to open it up, it captures that. I don't know what you want to call it, payload, but it basically captures it, and you replay it back to the car to open the door. And this is the same guy who actually, it's my buddy Sammy, he created the lock, the master lock, breaking it with less than 8 tries, and he did the whole key sweeper, breaking the wireless, what is it, for the keyboards, for Microsoft keyboards. same guy who's doing this type of research. So it's mostly left to researchers who are actually looking at this stuff because it's actually real world problems, affects people's lives, your cars, your house, it could be fires, it could be whatever, just your security of your files, whatever it is at home. Nobody wants their info to be kind of freely available and out there and posted, and it's kind of my job to do my due diligence to make sure you guys are secure as consumers and don't have to worry about it for smart home devices, routers, whatever it is. So I think this is like first time sniffing BLE traffic. It's like $30 to get one of these boards too, the Bluetooth LE. Android app security. Oh my gosh, Android app security is ridiculous. I test these partners because we have ODMs basically create the whole app architecture, and I'm going through these things like, wow, they have obviously they have no training. They're developers. It's cool. It happens. It's not their job, but they learn over time after you find all the vulnerabilities and you kind of walk through them and show them, hey, this is why this is an issue. But again, 10-man team, 4 or 5 developers, just trying to get something that works. Stack Overflow, like everybody else who codes, is their best friend. My best friend too, but for them it really is. And you have your whole usually like hybrid apps. So hybrid is almost like an Android app with the web view. It's almost like a web app basically. But like the browser through your phone and through your app, you get access through the local classes and things inside your phone for Android. So you have security issues, you have security privacy issues, client-side issues. You have forms and parameters that have to be validated. They're taking trust in frameworks for Android, anything else. Web apps too. All the permissions. They're using things like PhoneGap, Cordova, to make it easy to build these hybrid apps. And these things require a ton of permissions, and they're not even looking, hey, do I need this Bluetooth, and I'm not even using it. Do I need GPS? They're kind of just, hey, it works, and that's it. So with Android, you kind of have about five key things and usages for Android security, and that is, activities, which you see, intents, how those activities are actually being displayed to you. You have broadcast receivers. Those are like push messages sometimes. You have content providers, how you share data within your own app. And that's also a big issue. People kind of leave it open, leave everything world readable to get access to that app. So usually, like with the Android security model, it's contained to only your user ID as the app. But when you have an open content provider, everybody has access to your app. Anybody can query it. Anybody can do what they want. So it's really, like I said, these mobile apps, Android apps, are controlling your home, controlling your garage door opener when you're not home, your Bluetooth LE lock that's communicating over Wi-Fi, whatever it is. You have memory security issues. Same thing with firmware, but you have buffer overflow still. They're still relevant. Within mobile apps. A lot of the IDEs in Android Studio, they help you out during the build process to not have to worry about this, but people uncheck it for whatever reason. People uncheck it for like ASLR and things like that to randomize the memory addresses. You have secure storage. You're storing. You have a camera. Things, looking at your room, your kitchen, your living room, things like that, and the videos are being saved to your SD card, and your SD card is world readable by any app. Anything, anybody can pull it, anybody can send it out, copy it, do whatever it is, whatever they want to do, and it's mostly for usability. For example, people have their galleries in Android. They want to be able to see in the galleries, not within a separate app in their own container. So, there's some little, security issues like that. Not little, actually. It's actually a pretty big deal to me and probably is to you guys. But, you want these devices to communicate over something that's secure. SSL, TLS. Well, I'd rather use TLS 1.2, but something called SSL pinning, basically forcing SSL transport communication from the client device, from the app. So the app is making sure on the client that SSL is happening right over. You're pinning to the fingerprint of the RSA cert, basically. Your domain, only, Balkan.com is allowed, not self-signed certificates, so you can't proxy that data. That's the reason why. You don't want somebody to be able to go into your network and see the calls between, me turning off my lights, me opening my door, my garage door. You want all that traffic to be encrypted That way nobody will be able to proxy that data with like Burp, for example, or Zap. Usually they're over HTTP interfaces or something like that, something similar. So again, Android app security is huge. Again, these apps control your devices, so you want to make sure they're coded in the most secure way. Without, I don't know if secure coding will ever be realistic, but just with these ODMs and people, even regular teams, aren't really fully up to date with Android app security. And depending on what API level you're targeting for Android, there's different features that you can take advantage of that people don't know. So there's access control features, like with content providers, for example, like Android API 21 or 22, something like that. So you need to keep it open, use a lower level API, or you can use something higher and outdate older phones. Everybody's using KitKat now, 4.4, Android 4.4. But PMs and people they don't really know what people are using. They're just worrying about the app working. User experience is their main concern. Feel free to ask any questions anytime. I don't have to, yeah.
Is it any different on iOS?
Yeah, next slide. Yeah, so again, they have, iOS has UI web view. Same thing, it's like a web browser within the app. Same type of issues, you have cross-site scripting, SQL injection using a form. Same web app vulnerabilities, same thing. You're using same jQuery libraries, same kind of JavaScript. It's the same thing, but now you have your phone, which you use all your numbers, all your text messages, everything in that device, and things to control your home. It's just another big, huge attack vector. iOS has different protection standards. They have data protection, so kind of store it securely in a way. You can store it in your keychain. You can store it securely after, everybody does it after you put the passcode on your phone, so it's like until authentication. But that's usually just, once you put your passcode, everybody does. It's unencrypted or it's in plain text, basically. But, so iOS SDK, again, memory stack, buffer overflows. They have iOS, by default, again, has stack canaries and to prevent from buffer overflows within your app. Even when you compile the app and build it, it'll tell you if there's memory issues, if there are buffer issues and things like that within Xcode. So that's pretty awesome on their part. iOS also does a lot, or Apple has a lot of documentation on iOS security and how to enable or disable, well, you don't want to disable, but enable a lot of these features. Again, injection attacks, same thing. We have black box assessments, so basically it's different to test the iPhone than it is Android. I could get into a whole mobile security discussion, but basically you have to jailbreak an iPhone to actually do auditing on the app. Unless you have the code there, but again, you want to have a jailbroken device. You can't use like an emulator in Android. And even when you do use an emulator in Android, like if you just S it up any, you want to use your own rooted device to actually overwrite the trust store of Android to use your own certificate, for example. So the difference is when you want to use a physical device versus an emulator. And Xcode has a simulator for iOS, but that's based off of x86 architecture. So phones are ARM-based instruction sets. So so you have a lot of freely available tools, something called IDB. It'll, tell you if the app is using data protection, for example. You can stream syslog live. So if the app's logging anything and you can't see it because you're not, within the app's kind of user permission, you can use something like IDB to stream all logs and see, if it puts, here's the token that I communicate to AWS for everybody's home, you know what I mean? So there's people who do that. They hard code credentials within their app, or they'll log it, whatever their private keys, whatever it is. Then you have, like HomeKit. Apple is trying to make it more secure in their own way with HomeKit. The cool thing, though, is that they have something called a secure element. So you can store things securely within iOS devices, like a TPM. It's a hardware security level that only that app has access to store those secrets. Android doesn't have that, unless you're using Samsung, like Knox, for example. But not a company that works on consumer or IoT devices is not going to specify only Samsung Knox devices. It makes it hard for their code base to update to only target iOS devices, for example. But HomeKit's cool only because, again, secure element. Everything else, you can go through your settings and stuff, and you can control your home via HomeKit. The HomeKit, I don't know if it's an app, I guess, rather than like Wake Hub or your own, Balkans app or whatever it is. You can control just HomeKit if you have more than different types of technologies there. Web app operational. Who's looking at ACLs from AWS? Who's looking at whitelisted IPs? Who's looking at getting DDoS, for example? Who's looking at logs? Who's looking at the communication between the web server, the app server, database server? Are they in VPC or are they publicly available? Again, have change control when things are being changed, code's being pushed. Third-party libraries. It's a ton. You can imagine this is a developer. It's like, what? They don't even know what's going on. It's a ton of things to worry about. Not even as security professionals, you can't be experts in every aspect: hardware, software, mobile, web. You could be pretty good. You're not going to be a master at one. And then you have RF again. RF's a whole other learning curve. Sorry, things hilarious. So we're going to known security downfalls. We'll start there. I got these from security reactions. They have like ones on DevOps reactions and stuff. They're great. It's kind of Jonathan Broussard. Basically, the process of devices and hardware and computers being when they're being manufactured. There's so many handoffs to different companies and different people and different code bases. Basically, how you summarize it, it's a security concern. Backdoors, manufacturing time. You always hear that. It's usually at the ODM level. ODMs are the guys who will have, hey, you send this user agent. Now you have root access to the server. All right, this router, this embedded device, because they're using it for debugging purposes, and they just forget to take it off. And a lot of their excuses are debugging. Like I put that there so I can make sure things are working. But it's like, dude, come on, it's a big hole. Like if you can do it, I can do it too. And again, it's just another layer. Like you have binary reversing. You can look through, static passwords and things like that. So things, what not to do with your IoT devices and how to keep them secure. So, we don't want to expose your UART pins, but if you do, you want to authenticate it with a long password. Because even if they do, try to crack that password, a 32-character password that's, randomly generated, they're going to have a hard time. Because you'll find talks like at DEF CON, if you guys look for IoT stuff. Even last year, they do find people who authenticate the UART interface, but it's like the same. It'll be like Balkan just to get in. You're like, okay, well that wasn't hard. Or they'll just do crack it, and they'll crack it within like 30 minutes because it's something simple. It's usually something simple because everybody has to know it for debugging reasons. I don't know why, but debugging reasons. And again, here debugging scripts and backdoors, user agents. I talked about that. I put a little present there because that's what they're leaving you. A little present for later. We're gonna come back and peep on you guys. So private keys on devices, whether it's firmware, whether it's private keys on mobile devices. Anything held on the client side, not a good idea, unless you guys have a secure element. Whatever it is, some sort of hardware encryption layer. The reason why we're not using it, in case you guys are wondering, like, why aren't you guys using at the firmware level, the hardware level, it's because price. When you get to consumer manufacturing, everything's down to cents. Like, secure elements, 10 cents, times, 100,000. And like, oh no, we can't do that. It's 10 cents. When it comes down to 4, yeah, we'll think about it. And it's like, because these wireless chips are like $3. I mean, no, I'm sorry, like 3 cents. Like these Broadcom ones, the margins are super thin. So, that's why they're not in use yet. So we're just waiting for it to get kind of cheaper, so we can justify it. Or, maybe we'll talk about that in the next couple slides. But, again, what not to do: default passwords, static passwords, and it could be in your firmware. You're thinking no one's gonna look through my firmware. My firmware is safe. No, it's not. There's people, like me and a lot of other guys who will rip it apart, extract it, and mount it up and take a look, just to look. Why not? Or you just look at the binary, cut out the strings, and grep where you want passwords or something that looks kind of funky. And then the other kind of big scary part is the hardware level HDL backdoors that can be, put by the manufacturer or ODM, but but whoever is actually assembling these devices. And again, they could say it's for debugging and just, push it aside, but it's a pretty big deal. And you hear a lot of nation-state concerns really around that idea. Go into conspiracies and things, but we don't want to do that. So embedded, how do you actually secure these embedded devices? Restrict shell, use some tamper resistance, epoxy, silkscreen. Again, it's just, you're just going to make it longer for, the researcher, the attacker, the people. These are targeted attacks. They're not, you haven't seen a worldwide, compromise on all these devices, IoT devices or whatever. But so they're targeted on individual, typically, on your home or whatever, kidnapping. There's a ton of different use cases. Again, very long passwords if you're going to have any authentication interfaces. Update your kernel, update your packages, whatever you use for your media, your file sharing, your web server, your embedded web server, anything like that. Make sure everything's updated. Usually these, we use like OpenWRT, for example. We use BusyBox. You're probably familiar with BusyBox and Android if you're rooting your device, but you want to pull out what you don't need for these embedded devices, not only for space, but for security reasons, because if you're leaving, Perl, for example, there, you have another whole attack vector that somebody can just target using Perl without you even knowing. We want to do secure updates, GPG signing over an encrypted channel, making sure that that firmware image is actually the image that we uploaded as a manufacturer. Not many people are doing that, and you want an SSL pin when you're doing that too, so make sure nobody can man in the middle and upload their own firmware to the device. That's another big issue that you kind of see all the time. Secure seed functions. We'll get into that right now. You want to verify and test code. Same thing, QA. You want to pen test these things too. You want to static analyze it. You also want to dynamically test it when it's making these calls. At the end of your secure development lifecycle, hopefully. So you should be in the beginning and the network discussions. You should be when you get the first iteration of the hardware and the software, and in the end right before it goes to production. And that's what we're trying to do at Belkin. So secure seed functions. Next TRL copy. You guys can take a look at that. That was pretty funny. But basically, this is a real issue. I don't know if it's going to go away. And what's old is new. C code, str copy, string cat, still being used like crazy. You might think the device is crashing, but hey, no, it's actually buffer overflowing. You just haven't exploited it yet. Regulatory impact, I'm pretty short on time, but FTC, basically saying implement secure by design. How are you going to do that with all these different hands, like all these people touching this code, all these different technologies? It's ridiculous. But and they don't even address the supply chain aspect. You know what I mean? So it's kind of a tall list to expect from a manufacturer or a startup company creating these IoT devices to actually, make sure it's secure. And there's so many layers. So privacy by design, security by design, both FTC and EU Commission. Right now, that's the only thing that has our backing as a security professional for a consumer company is, hey, FTC is going to get on us, we're going to get fined. Other than that, we have nothing. It's basically my instinct, hey, this is insecure, we shouldn't do this. Everything else is like usability. If it works, it works, and if we don't think it's safe, as the PM will make the decision, then it's based on their discretion. Again, they're not addressing IoT supply chain. But how can we make it more secure? I'll say by liability, meaning put it in your agreements with your manufacturer, put it in ODMs, making sure that they do test their code. That if they don't, whatever, we're gonna take away $5,000. I don't know what it is. You can do whatever, just any type of repercussions, holding them liable to the security bugs or actually making them go to training. Hey, you guys have to. Does your team go to training? Security training. Have you guys ever? Whatever, some sort of questionnaire, and then have that in your contract, so they're aware and make sure that you're serious. That this is a real issue, and I don't think anybody's doing it. But this is something we're actually starting to do with our driver vendors, our ODM vendors, and things like that, just to add a level of security. Legal repercussions again, community projects. I'm actually leading the embedded security AppSec project for OWASP, so. We're going to have a call next week if anybody's interested. I have a list of about 20. I'm going to get it down to 10. Make it more digestible for teams to actually use practically.
So we have the whole IoT top 10, but these guys are from HP, good guys, but they don't know how these devices are being made. I see how it is from day one to deployment, mass production. Security into SDLC, like I was saying in the beginning, the middle, and the end type of situation. And then, maybe we can make some sort of certification, how Zigbee and Wi-Fi does. Make it some sort of, security or alliance, whatever it is. That's one idea. But who knows? Yeah. Firmware is typically readily available. You can download them. You could, yeah. I suggest. What's that? Oh, I'm sorry. He asked if we have any open source firmware and can we basically encourage people to work with the community. Yeah, so he's asking if, for open source firmware, do we, I guess, can you pull and merge your code over to open source software that we use? And we do. We have everything GPL. We push. Yeah, no, for sure. Yeah. We incorporate fixes. We have to. We use these things. Gets a little hairy there, but yeah, we do. And I encourage people to actually look at these drivers, these firmware images. That'll help me and that'll help everybody else because there's not a lot. You don't see Netgear guys or other security IoT vendors out there who are actually looking at this type of security attack surfaces and things like that. So again, it's just defense in depth. You're never going to be 100% secure. Again, you have different, you might be secure at the web app level, might be secure at the mobile level, but there's still hardware, they're still embedded, you still have low-level secure coding issues. So it's all about, just creating, defense strategies and what you can do to make it kind of harder, slower for the attacker, and make it safer for you as a consumer who has an IoT device. So there's things like build it securely, OWASP, like I was saying, top 10, embedded, bug crowd. We just finished the bug crowd bug bounty for Belkin. It was okay, but again, not a lot of people, it's kind of like a niche kind of skill to look at these devices. We sent our Link LED bulbs. We didn't get much with it, but we're open to anybody. You don't have to be, it doesn't have to be a bug bounty, but you guys can always help us out. We'll send you devices, whatever it is. If you guys are gonna look at it, we'll take it. And then Build It Securely is a group of researchers who are actually doing this. There's not too many of them, but they're trying their best to use expertise within what they know to look over these devices. It could be like medical devices we're looking at and just regular IoT devices. Yeah, thank you guys. Any questions? Yes?
Is your slideshow available?
Yes, I think it'll be on YouTube as well, from what I understand. But yeah, if anything, I'll tweet it out. I'll share it with you guys. Yes?
Would these vulnerabilities also affect phones
I'm sure they do, but IoT devices, they're not targeting those. Maybe government devices that aren't, consumer available. So my perspective is more consumer, not enterprise or like government yet, because